So if you remember when we talked about the normal distribution and the standard normal distribution, we said that we have two sets of numbers. We have the numbers on the x-axis. So these represent the x values or the z values. It depends if you have normal distribution. So we have x values. If you have the standard normal distribution, then we have the z values, and we have the other set of values, which are the probabilities values, which are the area under the curve, right? That represent the area under the curve, or that represent the probabilities of the of these x's and z's or z's. In the previous example, what we had the, suppose that this is z. So in the previous example, I used to give you the z, so this is 0, because it's a standard normal distribution. I used to give you the z, and the question was asking you to find what? To find the area on the left or on the right of that value, right? So in this question, for example, we can say the probability. What is the probability of z less than 1.2? So what we did actually, we go to this norm .s.dist, open parentheses. I don't like it. Okay. P of z less than 1.2 is equal to the norm .s.dist of 1.2, comma true. That's it. Then you get the probability value, which is the area under the curve. But now, let me get this value, by the way. Norm.s.dist 1.2, true, done. It's 88%. It's 8.849. So this is 0.8849. So this probability is associated with that z value. So the probability that the z will be less than 1.2 is about 88%. Now, what we are going to do now is the opposite way around. I am going to you'll be given the probability, and you are going to give me the z value. Now, if I say that the probability of z less than certain z is 88%. To distinguish between the z and z, there's the capital, there's the small. If z is less than small z, what? Okay, if the probability of z less than certain z is 0.8849, what is z? This little z. Right? Now I give you the probability, and I need you to give me the z value. That all of the z is less than this z value. So you have to locate now, where is that z? Is it here? Is it here? Or it's here, on the right? If it's in the left, then this statement doesn't make sense. Because what the question says, the area at the left-hand side of this little z is about 90%. Again, the area at the left-hand side of this little z is 90 or 88%. Is that 88%? No, it's less than 50%, because we know that the middle is 50%. We have 50% in the left, 50% on the right. So z cannot be here. Z should be on the right-hand side, should be here. Because now the area at the left-hand side of this z, that makes sense, is going to be greater than half, which is about 99 or 88%. So our z, the one that we don't know, is basically here. So we have to find that z. We have to find that z, that the area underneath the curve and at the left-hand side of this z is 88%. So this one is 88%. What is the z? In this case, what we are going to do, we are going to go to Excel and do what? We're going to say the z equals, we don't write z in Excel, but you write equal norm dot s dot env, the inverse of norm dot s dot env. Then you write the probability, then you get the answer. And the answer is technically going to be the same value we got before, because we used the same value. So z is going to be 1.2. So now to put all the puzzles together, the p of z that less than 1.2 is equal to 0.8849. Another example. If I tell you that the p of z is greater than a little z is 0.2, what is z? The same thing, the question gives you the probability and asks you to find the z. because the p is equal to 0.2. The probability equals 0.2. Let's graph it, because we have to locate the z first. This is 0. The area, what does this mean? The area at the right-hand side of this z is 0.2. Right-hand side of this is 0.2. So is it here or it's here? Is it right or left? Correct, it is right. Because the area at the right 20%. Because you can't be here. Because if it's here, the area at the right is greater than. The area at the right has to be 20%. So this is the only place. So this is my z. But Excel, this is 20%. But Excel do not understand the right-hand side thing. So immediately what you have to do is tell me that, oh, the area on the right of the z is 20%, then the area on the left, all of this, is going to be 80%. Why do we need 80%? Because this is the number that we are going to use in the norm.s.n function. Because in Excel, we cannot have that one, right? Excel cannot use the area on the right-hand side. Excel can use the area on the left-hand side. If you plug in the area on the left-hand side, still Excel can give you this value. So we can say the z value is what? Equal norm.s.n, not 20%. We're going to plug in 80%. If you plug in 20%, Excel will understand it that you are plugging this value here, 20% here. So it's going to give you this value here, the negative z value. Okay, so you have to be careful. So now what we did is we plug in 80% to get the z, and if you plug 20% or 80%, what we get? 0.8416. So this z value, 0.8416. So how to put this together? The probability of z greater than 0.8416 is 20%. Okay, so you have to just make sure that you get the difference between the previous example and that one.